In section 7.2 part B, we're going to continue with u substitution, but now we're going to look at other rules. So previously, we had a quantity to a power, and that was what we picked as u. So let's see some of our other options. If we have division, as we do here in example 1, a good choice for u is often the denominator. So here, my u is going to be x squared minus 3x, in which case du is 2x minus 3, and again I am going to write that in differential notation with the dx there as well. The same rules for substitution still apply, so everything in du has to be in my problem, which is the case here, so I can rewrite that as du over u. And secondly, that my resulting integral has to be something I can actually integrate. Now if we first need to rewrite that as an exponent, we certainly can, but this is our special case. Remember, we can't use the power rule in this case. Instead, we get the natural log. So substituting back, I get the natural log of x squared minus 3x. Now, technically those absolute value signs are supposed to go in there, and I'd have to put parentheses anyway, so I might as well be better and put the absolute value signs in. And of course, plus c. As a general rule, if we're picking this denominator, we're going to expect to get du over u for my integral, which means I am going to expect to get a natural log in my answer. Let's see another example like that. So once again, I have a denominator, so let's go ahead and pick that denominator as my u. So here my du is 3x squared plus 6x, all dx. Now I can pull a 3 out of that, so I've got 3 times x squared plus 2x dx. All of our rules with constants that we saw in our previous section also still apply here. So I have everything I need except for that 3, but since that's a constant, I can get that. So let's do just a little bit of rewriting first. I've got my denominator. I've got my numerator. Remember that dx on the outside, you can certainly put in the numerator as well. So I need to multiply a 3 on the outside, which means I multiply its reciprocal 1/3 on the outside, since I put the 3 on the inside. So there's my du. Again, I put the 1/3 on the outside as a reminder to myself that I will still have that after I've substituted. So again, that is my special case, so I will get the natural log. So my answer is 1/3 times the natural log of x cubed plus 3x squared plus c. You do not need to do any special log rules to move that 3. You can just go ahead and leave that as a 1/3 out in front. Alright, so that is our second rule of thumb, which again is when we have a denominator. My next rule of thumb, if I have e to a power, picking that exponent is generally a good choice. Remember, we have a rule for e to a constant times x power, but we do not have rules for anything else. So here I have e to a power, so let's pick that exponent, x cubed. So then du is 3x squared dx, and I have the x squared, but I'm going to need that 3. So I'm going to get e to the x cubed power. Then I've got my x squared dx. I need to multiply a 3 on the inside, so I put a 1/3 on the outside. So I get 1/3 times the integral of e to the u du. So once again, if I use this rule of thumb, I'm going to expect to get e to the u du as my integral. And as we hopefully remember, that's our new favorite integral. So my answer will be 1/3 e to the x cubed power plus c. So number 4, that 2x plus 1 is all up in the exponent. It's fairly simple, but it's more than just a constant times x. So this is enough that I'm going to have to do one of these u substitutions. And here I'm going to need that a 2 out in front to compensate, so that I get the integral of e to the 2x plus 1 power times 2 dx. Since I multiplied a 2 on the inside, let's multiply a 1/2 on the outside, so that I get 1/2 e to the u du. So again, I expect to then get an e to the u once I've integrated. So my answer is 1/2 e to the 2x plus 1 power plus c. So that is our second rule of thumb. Now we're going to have a couple of harder questions where we might be able to do more than one rule of thumb. So looking at example 5, there's two things I could pick. I have e to a power, so I could pick the exponent, but I also have a denominator. So how do I know which one I should actually use? Well, let's try letting u equal that exponent, 2x. Okay, well in that case I get du is 2dx. I don't have that 2 as a multiple, but it is just a constant, so I can get that without too much difficulty. And I would then get e to the 2x times 2dx over e to the 2x plus 5. I do note this plus 5 is not in the exponent, that is outside the exponent. Since I multiplied a 2 inside, I'd get a 1/2 on the outside. Well, I have everything that I need for du, but when I substitute, I get e to the u du over e to the u plus 5. I don't know how to integrate that. Up till now, since we've really only known one rule of thumb, we haven't really worried about this case. But this is why I always say there's certain things we want to keep in mind with du. So if you don't have everything you need for du, particularly variables, or if you get an integral that you don't know how to integrate, that doesn't mean we can't do it. What it means, generally, is that we probably picked the wrong u. So here, that is something I do not know how to integrate. So, let's try something different for u. Well, we said we have a denominator, so let's try picking that denominator for my u. In which case du is 2 e to the 2x dx. Now I don't have that 2 out front, but just as before, I can get it. So this is going to look pretty much the same. I've got 1/2 times the integral of e to the 2x dx. I can put the 2 either out in front or there. It's all multiplication. The order doesn't matter. The difference, these look the same, but now as I substitute, I'm going to get 1/2 du over u. And that is something I know how to integrate. So my answer is 1/2 times the natural log of e to the 2x plus 5. And I'm going to stick my plus c down here just because I've run out of room. So as you go through these, especially the harder problems, we might see problems that our first choice for u doesn't work. So again, if that happens, don't worry, just try another u value. Especially the first time you do these, that is probably going to happen a few times. Alright, let me do one more example. Now this is not quite a rule of thumb. I'm going to call it a rule of thumb because it's going to act in the same way. If you have some sort of log, which it does include the natural log, then that is often a good choice for our u. So here, let's let u equal the natural log of x. And as we hopefully remember, the derivative of the natural log is 1 over x dx. Now here, I do have everything I need, but it might be hard to see. So I'm going to rewrite this as 1 over the natural log of x times 1 over x dx. So this is the same thing. Again, I'm just writing it in a slightly different form so that I can see. Here's my u, and then here's my du. And again, I often do those rewrites so I can see that substitution a little bit more easily. Well, this is the special case that we remembered a few minutes ago, so I will just get the natural log of u when I integrate that. So my answer is the natural log of the natural log of x plus c. Now that is not something we've seen before. As it happens, we can have that. We can have the log of a log. Again, we don't see it very often, but that is certainly something we can have. So this is part B of section 7.2, where we now have all of the substitution rules that we will learn in this class.